Dan Mahoney with ISC. My talk is FROOT on BSD. It's all been FreeBSD, but from alpha to now. And the requisite slide that kind of covers my talk is XKCD 705. You've probably all seen this. It is an utter classic. And if you've ever been to ISC's corporate headquarters, you'll understand when we had one in the Bay Area, just how true this was. We've tried to keep FROOT, which is our root DNS server, uninteresting, which is good, but we've learned some things over time. So a couple of quick housekeeping things. If you want to just shout out questions, I'm fine with that. If somebody else is looking for hands and handing out a mic, that's fantastic. If I do this, it's not so I can give you the side eye. These are prescription sunglasses, and they're all I have on me right now. And I'm not going to get into heavy BGP stuff, heavy peering stuff, or heavy routing protocol stuff, because those are mostly OS independent and OS agnostic. I can talk about those all day if you let me, but this is mostly a BSD-centric talk. There's going to be a bit of Puppet in here, but it also has to do specifically with how Puppet has managed to play well using its core libraries in the BSDs, as opposed to just, hi, here's my 20-minute talk about Puppet specifically. If you saw Roller Angel's talk earlier today, Roller's a big Ansible guy, and there'll be parallels there. I don't use Ansible as much. I don't know what Ansible does better, but at some point I'd love to see a side-by-side talk happen, just because I think that'd be cool. As for me, I've been playing with FreeBSD for longer than I'm always comfortable saying. I started a dial-up ISP in 1999 that a friend of mine had bought from a friend, claiming this internet thing was the next wave. I worked at a dedicated server farm for a few years, and when we wrote a custom ticket system, they're like, okay, we just need a button that says escalate to Dan. That's okay, because our baseline texts were just like, here, you deal with this. And I started with ISC in about 2008. We've reorganized a couple of times. There were a bunch of things we used to do that we've gone back to core competencies. So I deal with our internal systems. I care and feed VMware. I care and feed a lot of our mail operations, which is more political and more complicated than you thought it was, because things like reputation and DKIM and DMARC and the rest of those have made life way more fun. So all of a sudden, deliverability is a fun problem. It is more of a full-time job than you think. And then I deal with FROOT. I'm part of a 3-person team that works with FROOT. While we're talking about this slide, we have Ellie Sattler from Jurassic Park. I do not actually identify as a 13-year-old girl, but looking at the way that park ran and looking at the way 950 Charter Street ran brings back some memories. It was, there were some stories there. It's also clear that of the 2 computer people in the movie Jurassic Park, I'd rather identify with this one than with the other guy, because he got eaten, and he was kind of a jerk. And that's not the reputation I'd rather smart people get associated with them. Is they're just out to grab your money and they're out to dick you over. Also, 30 seconds of soapbox. Gender's a construct. Thank you, Canada, for setting up a lifeline for trans people that you can call from the US when the US has decided not to. Please reach out to other people who do not look like you. Sometimes you will see a person in tech who doesn't look the way you expect, or that matches their name, or that maybe doesn't look like they did the last time you saw them. People are humans. Treat them that way, please. All right. This is not my Linux bashing slide, but maybe it's a little bit of a Linux bashing slide. There's a website called the Linux Documentation Project, which feels a lot like a bunch of people who found a monolith in the desert and started writing down details of it and trying to describe it. and though it just fell upon them. That's what documentation project says to me, whereas the FreeBSD's documentation project is freebsd.org. I've tried running Linux. I continue to interact with it day to day, but I've been doing BSD for 25 years, and from the get-go, the questions I've asked I thought have been reasonable, cohesive questions, and I've been told I'm either using the wrong distribution, because there were many of them then, and there's more now, or why would you do that? That's a dumb thing to do. A base example was I was running Red Hat 7 from scratch, and I don't know if you know this, but when you install Red Hat 7, it installs a bunch of packages that you don't need. You go to install the base level of systems and you get cups for some reason. You need to print with your web server. And so I tried installing nothing, unchecking all the boxes saying, give me a clean system. I'm like, okay, but I want a C compiler. So I figured out how to install GCC. Download Apache, try and run it, checking for GCC. Yes, checking to see if GCC works. No. Hi, how do I fix this? Well, that's stupid. Why wouldn't you just use the installer? Use Anaconda. Thanks, guys. So the same things have been true. We have good man pages. We have interface names that actually stay consistent, that are not ENP32S0P0. That came up in another talk. You can actually configure your network with ifconfig. You can, we have standard startup scripts that are largely the same as what they've been for 25 years. We don't have this thing called systemd, which, is a thing. This is me soapboxing just a little bit because I love the project and I still feel like the weird kid in the room who, why do you run that, not Linux? Well, here's why. The other two members of my team, Ray and Omar, both of which came from the Linux world. And I keep hearing stories about, well, my BSD system is doing this now, and oh, this just works, and oh, this is elegant. Like, one of us. The general logic here is that BSD is, to me, and Stefano and Roller also touched on this, it's a way to work smarter, not harder, and FreeBSD doesn't seem to be in a rush to throw the latest blockchain AI CUDA nonsense into the operating system because that's what somebody upstream is pushing into it. So ISC, we'll touch on that briefly just so you know. We're a 501c3, we're a nonprofit. We, for the longest time, were headquartered in the San Francisco Bay Area. Our corporate DNA, our corporate history is we were originally a sort of skunkworks project at Digital Equipment Corporation, which founded the Palo Alto Internet Exchange. And as Internet exchanges became a thing, Paul Vixie moved on from that to do software that kept the internet stable, was given a startup grant, and so my past manager before Ray his lab was the one that had built the first firewall at Digital Equipment Corporation. And these are the people I've come to work with. I'm like, I might be home. This is cool. We make core internet software. We make the ISC DHCP server, which is now just strictly in maintenance mode. And we make Bind, which you might have used. We make a new DHCP server, which is Kia. It's a DHCP server that follows more modern standards, is more extensible, and has more Python pluggability. And that's what we're trying to transition people over to it. This is a lot of history, and most of it has a rich oral tradition. But if you ever find Paul Vixie, buy the man a beer and say, so whatever happened? This is a bookshelf that I found the first day I worked at ISC, and you can see there's every kind of operating system on there, all boxed copies, a good number of which I would become responsible for the care and feeding of because we had a lab where here's the Solaris box we test Bind on, here's the HPUX box we're testing Bind on, here's the True 64 Unix box we're testing Bind on, and you can see over there's old copies of BSDOS and BSDI and stuff like that. I didn't get to play with those, but just seeing them there made me realize, okay, we're going back. Also, 950 Charter had a bunch of hosted projects. We had a third of Internet Archive sitting in our data center. We had a rack about yay tall of the FreeBSD projects, dev machines. We had a full rack of equipment for the Network Time Foundation, that we had become the home for wayward open source projects. And we had a cooling plant and a power plant that, yeah, did some things. It was, if you've ever seen shows like Warehouse 13 or Babylon 5 or Deep Space Nine or Doctor Who, or you remember the Millennium Falcon, that building had a character of its own. It was persnickety, it was special, and it didn't like to be left alone. It could magically tell when I went more than 100 miles away from it reliably. We would fail an air conditioner, we would fail a Liebert UPS, we would fail something, and so it needed me there. Not related to that, this machine here, which did not fit into a rack at all, that I had to go buy crazy standoffs after bringing the rack down to Home Depot and figure out exactly what size thread they took, is the current FreeBSD mirror that we host. Thank you to Cluster ADM for setting a machine that hung out of the back of our rack by 6 inches and make it so I had to go do this. That was IX Systems work. And I had to go to the data center 4 times for that one. So the fun continues, but I digress. We still do try to help the project. We're still not a stranger to anyone here. And I'm also a maintainer for a couple of ports. I'm trying to take over maintainership of more. I'm trying to push my changes in reasonable ways, like what Michael said in the last talk. But it's a journey. And right now, I focus on the DNS. So if you don't know what the DNS is, you're using it right now, all the time. If you don't know what a root DNS server is, this is my quick 3-minute slide of these servers are at the apex of the DNS. They tell you where to find com, which will tell you where to find google.com, which will tell you where to find mail.google.com. You can ask them any question you want, and they will only tell you about the next layer down. That doesn't necessarily mean that all the questions that we get asked are intelligent questions. Lots and lots of people have misconfigured boxes that will keep sending queries up to them and ignore the caching. And then they may fall over to another server in their search list. But they think the right idea is the root servers are just like Google's 8.8.8.8. And I don't know how they're operating, and we have no way to contact these people and see them because we just see IP addresses. It also means that some bad routers will send us everything from .local and .netgear and all the domains that don't actually exist in the root. And since their local servers don't know how to do it, 90% of the queries we see are garbage. All we're sending back is referrals. We do not do any recursion on the root. So back in the day, before I got to ISC, before we did the thing called Anycast, it was 2 DEC Alphas in a rack. And if you've not seen a DEC Alpha, it's a box about the size of that chair there, with big stinking honking disks and real Ethernet interfaces. And there were 2 of them only so that when they started doing upgrades on one of them, they could go, okay, good, now we can reboot that one. Minimal downtime, that was how we did it. And we were the first, and I'm saying we here in sort of a honorific fashion. I was not around for this, it was way before my time, to do something called Anycast, where you take 2 machines and you announce them both into your local routing protocol, which pushes them up into your global routing protocol. Using something called ECMP, Equal Cost Multipath, you can make it so that each server will continue to receive the queries from a given host out on the internet. There's a tuple that's defined in your router that will make sure you always get the right queries. Obviously, both machines are saving the same set of data, and most of the time in the DNS, it's one query, one response. So there's not a lot of state there. We did that first. I think 6 or 7 of the root operators now are doing Anycast, and they're not just doing them between 2 machines in the data center, they're doing them globally. So we currently have somewhere around 50 nodes that are all announcing themselves out with a single IP address, 2 if you count the IPv6 address, into the world. And most of our nodes are announcing a slightly different net block that takes precedence over the slightly smaller net block that is global. So if you are at a site where we speak to you locally, you will get the local net block. If you're not at a site where you peer with us at a peering exchange or via direct peer, you will only see the global. And this way we can do things like keeping local traffic local. There are some no export BGP filters that basically say, don't let this route leak out. That doesn't always mean people respect those, and that's a regular thing. But that's more of the routing side of the talk that I could give it an anog or something that doesn't really play here. In the more recent past, when we scaled out to more nodes than just the one at PAX, it looked like 2 Cisco routers, again, so you have a redundant pair for failover. Usually each one would lead up to a separate transit. 2 managed switches. You really only need one of those, but it was to guard against hardware failure and stuff like that. And then 3 servers. 2 of them would just serve the root zone, same as in the original design. Plus, we put a management box in that had basically a local resolver and a serial concentrator on it so that it could talk to all the other things. That Z box wasn't in the critical path, but it was, as my coworker described it, the secretary at the door. For those of you who've moved in the community for a while and know Peter Losher, who also went by the handle TARDIS, most of these were deployed by Peter's Sky Miles. I mean, ISC paid for him to travel, but as he went to conferences, that was a lot of the deployment was, while you're here, you're going to set up a node, you're going to meet the local ISPs, you're going to meet the local IXs, and this will be the case for the foreseeable future. That's foreshadowing. Unfortunately, with any router, especially ones as old as Cisco 7200s, you run into a couple of problems. One of which is the size of the global routing table. The other is that these things eventually go EOL, and that's sort of a bad luck. So what we've arrived at now is as our routers reach DOL, as we start approaching the fact that the max RAM you could put in that won't hold a global routing table anymore, we also looked and said, oh, but the software routing stacks are really solid. There's a product called the Berkeley Internet Routing Daemon, BIRD, and interestingly, I think they stole our name. And also, interestingly, I think they never actually operated at UC Berkeley, which Bind did. But sure, maybe it's just because they're using the BSD license. But we have a single machine sitting in a rack doing all the functions of the prior stack. So it is speaking BGP to every peer at an exchange. It is speaking to us back home on its main OS connection. And we have an iDRAC on that, which is a piece of Dell hardware that basically gives us full out-of-band management. I can extol the virtues of Dell iDRACs over pretty much every other management configuration ever. They are really solid, and I've developed somewhat of a reputation in our little group as I am the iDRAC whisperer. I've managed to squeeze interesting things out of these that really could be their own little 10-minute lightning talk. I've managed to get the installer for FreeBSD running, the TUI installer, running in an SSH session to the iDRAC itself with no media loaded over SSH. We don't usually do that because we take the 10 minutes to log in and do an install, but it's a neat hold my beer thing. So we've got software routing daemons that speak BGP, and because we don't want to pollute the management side, when I'm SSHing into the box to do a Puppet run or do a FreeBSD update or update packages, I don't want a peer stealing my route to the mothership. The only system that sees the big routing table that's been lured from the BGP peers on the exchange is a second fib. That's sort of the magic, that the second fib looks like the routers that we used to have in the old stack, and then internally we just have a short default static route. We're also doing our automation with Puppet. Roller did a really good talk about Ansible earlier, and again, I'd love to sit down with them and say, is everything I say is true here with Ansible actually true here with Ansible? Because I say some things. Anyway, because of the way the networks are different, we had a problem. We were getting 2 dedicated transit connections in, and what we really needed to get was, yeah, we need a transit that's really just going to be the management interface for our box, but now we need a second management interface just for the iDRAC, and while we can firewall that somewhat, the iDRAC does support its own ACLs, we also need you guys to let us do more than just BGP. We need you to get out of the way so that we can do our own job. So there was a little bit of reconfiguring at the transit level that required getting in touch with local sponsors. That's not necessarily FreeBSD specific, but you'll see why it's critical in a minute. We also had this problem with purchasing. I can buy a Dell PowerEdge right now, but mailing that Dell PowerEdge to Haiti gets hard. Mailing it to the UAE is really hard. You have to be an expert in international logistics to send these things out. You have to be cognizant in things like harmonized codes and the weird language of that. And every country is different, even inside the even inside the EU. Things get really weird. On top of that, it can cost twice as much. You can send that thing out and you will pay more in VAT than the value of the service. We're a nonprofit. That feels like a poor move. We also found out sort of late in the game that Dell's warranty doesn't apply. If you buy it in the US and then you say, hey, I have a server in Amsterdam that I need you to have a Dell tech show up to and replace a hard drive in, that service only applies in the US. So all of our purchasing is a little bit complicated there. So what we've done is, if you're an IX operator, if you're an AM6 or you're an MSKIX or a whatever, we'll say, okay, I'm sure Dell is a global brand, go buy a box in country, or if you have a spare, slightly out of warranty Dell box, set it up for us, we'll run it for you. At the end of it, if we dissolve our agreement, it's your box. But it's of a benefit to you. It benefits everyone in your country or in your region to have faster DNS service. It's something that you, as an exchange operator, you're typically asking people to pay for access to your exchange, so it's a value add for you, and the internet wins. We also work with a CDN to do some of our offload work, but we've held the belief that we need to be able to stand on our own even if the CDN remains up. That why are we doing this if our job is just to be the people who signed a contract with the CDN? That's sort of layer 9, but a lot of the DNS, especially root DNS, is layer 9. If you don't know what layer 9 is, it's a very, very political thing because it gets into the ICANNs and the IANAs and there are lots of meetings about this stuff, and we didn't realize, I didn't realize just how much of it would be politics when I came into it. I just like running systems, but it's woefully political. So let's get to my fun stories. We're doing this forklift upgrade thing. Turns out people are slow at ordering hardware. Also turns out it was 2020. Nobody's buying hardware. Nobody's going to the data center. If I call somebody and say, hey, look, I've got a system and my root partition's too slow or too small and I want to run FreeBSD update on it and it's crashing, so I need you to go down there and burn a CD for me. In 2020, people are not willing to burn CDs, turns out. Can you just go down there like, no, I'm not allowed to leave my home. Your thing is working. Call me back in 6 months. So we had I want to say it was FreeBSD 9 and 10 that were going EOL, roughly around the same time. We had a copy of Poudriere running in case we needed to build packages for those, but we couldn't do kernel updates. These machines were incredibly hardened. I wasn't particularly worried, but there was always the what if. I mean, it's 2020. What else could go wrong in 2020? Some of those systems that we've been trying to replace were even i386. It's a fun move. So I've discovered on 1 or 2 machines that I tried to do upgrades on that FreeBSD update will let a system die on the table. It'll fill your root partition midway, and then you'll get warnings about, LDSO, invalid file, or something like that while it's running. And then you hit Control-C and you're a system where you type ls and it says invalid object. Oh, that's not great. So I came up with a solution, and it says combat story up there, and I'm not kidding. So I tried it in a VM, and then I just said, okay, guys, I'm gonna try and get all the systems up and running tonight. I just had way too much coffee, and I'm just SSH'd into everything at once, and I blow away my boot partition and untar an MFS-BSD file. At this point, I'm almost at the point of no return. If I hit reboot, I'm hosed. I pasted some nasty shell script into my root prompt that basically took my netstat, my ifconfig, and my hostname and stuffed it into boot/loader.conf, which MFS-BSD, and only MFS-BSD, knows how to populate those back into a running system. And then I typed reboot. And I ran a ping-a, which is the ping with audio options. So you get a ding, hoping for that heartbeat. It's like when when the space shuttle starts landing and there's the communications blackout and you're waiting for somebody with the binoculars to spot it. Please, for the love of God, come back and ping. And it is a sweating moment. But it did. And so, okay, you're up on a box. You're running in memory. Your old operating system is sitting there. And MFS-BSD comes specifically with tools called destroy geom. Again, it's a scary tool because it will mop the floor for you. It will get whatever the heck you have out of the way, and then it comes with another tool called ZFS install that literally knows how to consume the OS tarballs right from the FreeBSD mirror site. And lo and behold, other than a few simple startup variables that I had to populate back in, because they had survived over from the bootloader as a lifeboat into my running system there, I rooted into my new install, pumped them back in, set a root password. That's not the root password we used, but it was a fun one for this slide. And reboot again, it came up. Your SSH keys are wrong, but we don't care about those. And then let Puppet do its thing. The box is back. Puppet brings in not only the rest of our security stuff, the rest of our users, the rest of froot services, the box is back to normal on a modern OS after that. Puppet does everything for us, and that was, don't get me wrong, this was not one box, this was about 25 boxes. Yeah, it was a night. And my coworkers come on to Mattermost. They're like, "Did you see the monitoring?" I'm like, "Yeah, I caused the monitoring. That was me. Sorry, I should have told you." But as of now, all the boxes I had to do that with have been replaced with the modern Dell machines. That was a nice trick to get us through the darkest night. It's an epic story, and that's why I'm sharing it here with you. But I tell people about this because FreeBSD lets you do this. FreeBSD just lets you, it's a tarball. If you can get on the disk and untar 2 files, you're good, you're solid. And as I looked at this and tried to describe this process to people, I had to go into my old documentations and my old scripts to see what was running. I'm like, why is this crazy trick not mentioned more in the handbook? Because I know other places that people would have been helped by this. and instead it's on Martin Matruska's little side page, mfsbsd.something.vx or sk or something like that. I'm like, this was a lifesaver for me, and I'm stunned that I discovered it. And since it runs in RAM, okay, sorry, my volume went down. I wanted to make sure I was still broadcasting. It's gotten me thinking about, okay, if I wanted to do a secure service, what else could I do that's completely RAM-based, that I could deploy an SD card or a CD-ROM or an ISO? Maybe not a physical CD-ROM, that's a little old school. But it's got me thinking in that way, and because it was, the Swiss Army knife, once you know what you can do with a Swiss Army knife, you get very, very aware of how much you can do with that tool. So I've got story number 2 here, which is that we have Puppet. I've mentioned it a couple times, and what Puppet does for services is it's aware of FreeBSD semantics for starting and stopping services. So it knows that to enable a service, you're going to be tweaking a knob in etcrc.conf or etcrc.conf.d/service name. It's aware of the fact that the sbin service command is what starts and stops services. It's aware of what mechanisms are used with service to do, is the service alive and running, and it can check if a service is running. It provides a really good abstraction layer. And what happens with Puppet is, since you're deploying discrete files with each service, so if you're running bind, and you're running Apache, and you're running SSHD, not the best example since SSHD is part of the core OS, but if you're deploying bind, and you're deploying postfix, and you're deploying, another service that writes to log files that need to be rotated and puts their own config files elsewhere in user local etc, it means that you've got the granularity that you're not trying to merge a bunch of config files together. You're not trying to merge together all of logrotate.d or new syslog.d. You're putting things in subdirectories. And I like that idea a lot. And so I came up with a service that runs on froot called announce-d. Yes, like so many services, that looks like the English word announce, like the past tense of announce, but it's pronounced announce-d. I wrote it, I say so. So it's just a shell script that runs and polls the DNS server running on your local host. If it responds cleanly, it adds an IP address to loopback 1. This is the routing magic that allows froot to withdraw its route safely if for some reason it stops responding. If bind dies and just refuses to start, this thing will say, bind isn't responding. It will rip the IP address off of LO1. Bird will say, hey, I can only announce routes to BGP that I have myself a route for, so I'm going to withdraw that. And so people who are living on the IX will get a route from our global nodes in other places to those things. The BGP session itself will stay up, but they'll basically be announcing their routes to us, but getting no route to froot from us. And again, if you have BGP questions, let me know. I never claimed to be a BGP expert, but I kind of had to be for this job. I'm still not an expert. Let me pre-clarify that. I'm not a CCIE or anything like that, but I know enough to do my job, which is how sysadmin works. As I mentioned earlier, the idea of writing a service like this is you want a proper startup script so that it starts. You don't want to just start it from rc.local. You want Puppet to check, is this thing running? Is it enabled in rc.conf or the per directory equivalent? And what that meant I needed to understand was proper rc.d scripting. So in that black box there, that's all that is in Puppet that says you have named that needs to be running. The first line ensures that it's actually started, and if you don't have the enable true, it'll do a one start with the service command. Otherwise, it'll just do a start. The enable command controls the named_enable variable in rc.conf or rc.conf.d. And this is the cool thing about Puppet. If you were on a Linux system, it would enable it in whatever crazy way systemd wanted for your specific distro. It takes some of that abstraction and makes it easier for you. I'm not saying you shouldn't also know how to admin your system, but it does make your service management more simple. But in writing a startup script for this, I read through the documentation. There's a nice section there with individual dots that say startup and management of a simple service. There's also startup and management of a more complex service where you need to have PID files exposed. I used the daemon tool to run this, and recent versions of daemon let you do things like expose a PID not only for the daemon command, but also for the child process that it's running. And so in doing this, I found a tool in ports called rclint. I'm like, okay, I want this thing to be future-proof. Let me run rclint on this. No errors. Cool. Let me run rclint on etc.d, or etc.rc.d. Oh, I should put in a PR for that. And I think I may have volunteered to take over fixing a bunch of mainline rc.d files so that they actually play nice with this tool. Mea culpa. Puppet also does a cool thing where it ties into our monitoring setup. We use Nagios. It's old school. It's not cloudy and special. It doesn't draw a bunch of pretty dashboards. It just pings things or runs an agent on your box that pings things or checks services and sends email. Now that sends email can be a script, it can call a pager, it can call out to PagerDuty, it can do whatever you want. A plugin can do whatever you want. They are just scripts that output status codes and extended status data. So turns out, because of the photos I showed you before with the overheating air conditioners and the overheating server rooms and the overheating everything and the airflow problems, I got really good at writing Nagios plugins a long time ago. So I've written tools to interrogate Liebert UPSs that just have a serial port coming off of them. And like one Ethernet port that only negs up at 10 meg half and only speaks SNMPv1, and you can't even set a community on without plugging in the serial cable next to the high voltage board. I've got pictures, I'll show you if you want. It's terrifying. I've written tools that, because we've had some older systems that got deployed with whatever RAID card we have or whatever RAID card was donated, it's whatever RAID is on that box. So we have a check multi-RAID that looks at TWCLI, SACLI, MFIUT, MCTUtil, Mr. SASUtil, MegaCLI, ZFS, Gmirror, and it will report, okay, we're pretty sure you have a single disk. It says DA0, but we're not 100% sure if DA0 is a fake single disk provided by your RAID card, or these other tools say there might be a RAID there present. And that's useful because sometimes you're SSH into a system and you realize, oh, it's still reporting a DA0, but it's broken. I've written tools to talk to old APC UPSs. We had a transfer switch and a generator, and the tool that interrogated those involved ring transducers. I'll let you figure out what that looks like. And then there's the Dell iDRAC. I've said nice things about the Dell iDRAC, but one of the cool things it can do is, if you look at a recent Dell at the SNMP MIBs, which I've spent way too much time in, there's a single OID you can look at that's basically analogous to the flashing orange light that comes on the front of the box. If you look at, there's a single health LED, or a single health OID rather, that will report critical if anything else is wrong in the box. After I get that, I can ask and go through all the OIDs I know about, check your storage, check your RAM, check your fans, check your power supply, check your everything. And so it gives me a one-point check to look at all of our boxes out in the field. Also, talking about RAID cards. Did you know that you can crash a RAID card by asking it for status too much? Especially if it's got a failing RAM or failing disks. Turns out, pulling a Michael Jackson on the RAID card and just saying, Annie, are you okay? Are you okay? Are you okay, Annie? Annie, are you okay? Yeah, Ask me how I discovered that. Anyway, because I'm not bad with the Nagios, and we have Puppet, there's something in Puppet called a virtual resource. You can define a single resource for a service in Puppet that does nothing itself on the box. But what it does do is, on another box, you can say, for every box I put this service on, run this loop, where you can deploy templates for each individual box. And that is stupidly cool, because it means by adding one line to my config manifest for every froot server out there, or one line per service in my config manifest, my Nagios self-populates. Everything that Puppet knows is alive and that has checked in recently will automatically wind up in Nagios. We also do fun things like we use custom facts inside Puppet that a Puppet run will run IPMI tool land print1 and it'll pull up your LAN IP. And we can look at that, and we can look at the DMID code of the box and say, oh, if it has this LAN IP, and it's also got a model number that ends in Dell, it's got an IDRAC, which means we're going to add this set of monitoring to monitor all these profiles, and it might have, otherwise it's a generic ILOM, and all bets are off for monitoring, but at least we can ping and SSH the thing. The consistency among other ILOMs is sort of not quite there. But since we're trying to standardize on some flavor of Dell, we're usually in pretty good places. But what I get from this is I get a bunch of files. Again, the magic of the rc.d files. Nagios knows how to just load every file in that directory, not just a single monolithic config file. So every host name has a single file in a directory that Nagios knows how to load, which gives us the ability to say, oh my God, I'm sorry, this is really, really ugly. I'm going to push a button here and it might do the wrong thing. There we go, sorry. That might wash out the cameras, I might have to switch back. But literally, all of these came from templates. I've pulled in 2 host defines, one for the v4 and one for the v6 host. And we don't monitor every service on the v4 and the v6, because if I'm checking my load, for example, I'm only going to be checking on v4. It's going to be the same load whether I ask it over v4 or v6. I don't feel the need to check it via 2 protocols. That doesn't buy me anything. But for a service like ping, I do care about both sets of ping. I do care about DNS latency on both service types. So all of this came from one type, and just adding, for every service I've defined in Puppet, I can go in and define another template that gets populated from this. And once you're used to doing it, there's a little bit of a setup step, because you have moving parts in like 3 places that you have to set up. But once you get in the rhythm of it, every time you define any service, you go through and say, okay, we've got the service set up, it runs, now we do the monitoring, and we never have to think about it again. It's a really great rhythm to be in. One of the other cool things about Puppet, and again, this is not my love letter to Puppet in any way, it's been frustrating, is that if you do things on a Git branch, it populates those with a tool called R10K into a different Puppet environment. So you can say, okay, this machine is in this weird class of things I'm monitoring, load only that environment, and it will run a completely different set of things. Puppet's descriptor for most services is the host name, so we can lump host names into classes. Those classes load. This is very Ansible-like as well. But there is a way to do development in a nice, clean way where you merge your Puppet manifest back into production. So this is what we get based on that single line. I don't think, this is a VM. I can't think of what else I would really want to know about a DNS server running on a VM. I've got all the, I know bind is alive. I don't really care about its performance because it's a stealth name server. But I do care about the rest of these things. I care about if it's overloading, because that means I need to adjust the VM itself. Most of the time, these things all read green, but it's kind of magic that I don't have to, every time I add a box, go in and edit a config file. It's great that way. So yeah, this is reiterating what I said. As soon as you deploy any host, you get on the box as root, you do package install Puppet 8, Puppet Agent-TV, and even if you have not defined a config for the box itself, we have a base config that deploys and gives it proper SSHD settings. We don't actually use PubKey authentication. We're Kerberos shop, so it'll turn off PubKey authentication, it'll turn on Kerberos authentication, it'll turn on GSS API authentication, it'll add the system using a script on the back end to our Kerberos domain and deliver a key tab into the files directory. It'll give us all the base level monitoring plus monitoring for any service that we've deployed, and it'll do all the firewalling. I say it right here on the slide, and I'm trying not to just read my slides. I'm trying to sort of talk freeform, maybe a little bit fast. Since so many of our systems are out in the world, in the big bad internet, firewalling is absolutely key for us. The only service we want to expose to the world is the DNS protocol. So IPFW is key here. The iDRAC can protect itself a little bit. The OS is its own problem. And then I came to a realization, which is that IPFW doesn't load from an IPFW.d file. You can set firewall type in rc.conf to a file name. You can set it to simple things like open or client or some other weird flags that I don't remember. But I said, why not? I just went through the work of learning how all of RC order works. I just learned how to write practical startup scripts with RC order. Why can't we take RC order and part it over to all of our IPFW files so that on boot, it just looks at IPFW.d and runs those lines in order. So as soon as you deployed a service, not only do you get monitoring, you get the firewall rules that precisely that service needs. And if that service needs to phone out to the internet for something because it's a caching DNS service that needs to contact other DNS servers, you can set that. If it's an authoritative DNS server, it doesn't need that. It just needs to get packets in. Okay, cool. We can put all of this in a rule. We can define a firewall type for each and have them all go in. I should probably, after this talk, have another look at the PR I put in and see if it's worthwhile. But we've gone in and we've defined, just like regular user local etc rc.d, there's meta classes that say, services, startup, networking is up. So we've got some meta classes called outbound, routing, and services that define roughly where in the tree things should be. We, if a service needs the routing daemons up first and it runs a service, we'll start that there. And then we've also got rules that say setup and final. So the setup rules will do things like, allow any to any via LO0, allow these ICMP types, allow these, set up the final, do things like let us say, okay, last of all, allow all from any to any, or deny all from any to any, regardless of what the sys controls have defined, that basically let us have full control. So for security reasons, I'm not pumping my entire firewall stack into my slides, but I've sanitized the one for SSHD just so that you can see what it looks like. So at the top, we have a rule called SSH_service. And you can see it has the classic RC order, require this, provide this, and before this. So all of the services run before the rules that let things out to the internet. We go ahead and we actually create a named table. And on a reload, that table SSH clients create will not cause an error. It will not crash IPFW to create a named table twice. And it adds a rule that says allow from what is at this time an empty table to me 22 in setup. Later on in the stack, this second rule is going to run after that because it requires the clients. It's going to add our VPN IPs to that same block. So for every single class we could do for a box, I'll give you an example. Our corporate jump host is only going to allow from the VPN. We may have other clients that will allow from other boxes on our network. It's just another define in Puppet that add another file into ipfw.d. Puppet will automatically restart any service it knows has changed. So on your next Puppet run, that file's in place, ipfw is refreshed, and suddenly you're good. We don't run Puppet automatically all the time. Some of the times we use a mass SSH command to push our changes out so that we can actually sleep sometime. But the idea here is this is the one missing service in the deification, that's my word for this today, that says, okay, how do we make it so that this is modular? And it's turned out to be a game changer because I'm not building a static firewall config that any config can break. Because it runs in a loop that says, for each of these, run ipfw on this file. If a file hands a crit, it jumps over to the next file. If I'd done these as a single unified file, as soon as it hit a critical error, it would drop the file. So you'd never get to your default allow. So this actually is a way cleaner, saner way to do things. And I'm running, what time do I run to? I think I run to 50. I may be done early. I'm sorry. So let me bring you to the third of my stories, which is Dell's DRM. Now, DRM seems to stand for a couple things in the BSD lands. There's the one that has to do with your video drivers, which I don't know off the top of my head what that is. There's also the... Rendering manager. Say again? Direct rendering manager. Okay. I thought for the longest time that it was like, so you can watch Netflix, like that DRM, the digital rights management. I'm like, okay, that's why your video card has that, so it can speak HDMI, CEC, and like sure, somebody wrote a whole module for that, that's fine. And the more I read about it, I'm like, no, that's not that is, but I don't play much with the video subsystem. So we've asked people to get Dell hardware. Sometimes they get Dell hardware that they've retired from active service. Sometimes the same network card they get is not something we've tested with. It's, oh, our reseller gave us this one, this is a current spec, or this is we bought a fleet of 50 of these and this is the network card that was in it. We'll give you one of our spares. Sometimes we get weirdness. Sometimes we get things that haven't been updated in a while. And so Dell makes a tool. I give an example. This does fit in my combat stories because this took us forever to figure out. When you're on a peering exchange or an internet exchange, they really hate when you put out broadcast traffic. They hate when you put out Cisco Discovery Protocol or Link Layer Discover Protocol or you're spewing OSPF traffic into the WAN. They notice that and they think you're a noob and they will jump on you for it because it's broadcast traffic. Everybody on the peering exchange with all their big expensive Juniper routers and Arista routers is getting that traffic thanks to your inability to turn it off. And so we had a Dell branded. It was made by someone else, but it was, it had Dell hardware or Dell firmware on it. 10 gig network card that was putting out LLD packets on its own. You did not see these with TCP dump. The card itself was doing this. There's a phrase I say a lot to a lot of automation stuff. That phrase is, stop helping. Please stop helping. I know you think that's a great feature, but it's not. Now there's a knob that you can break into the BIOS to and turn that feature off, but it wasn't in our version of the firmware. Because of course it wasn't. So we had to do a firmware upgrade. Luckily, we already had thought about this. Dell ships a product. I could have gone on the Dell website, found the one version of firmware, logged into the iDRAC, uploaded the firmware, hit deploy, and it would have been good. But Dell makes a tool. It runs under Linux. I think I Linux bash it on the next slide. It's a Java program that will poll Dell for an entire range of servers, download all the possible updates and patches for them, and cache them on a server that you have on site. It will, the packages are signed, so I feel comfortable doing them over the internet. There's nothing secret about these packages. So I can go, if we have an FRoot server in Guam, and I say, you haven't been updated in a while, I can go into one page in the iDRAC, either via the GUI or via SSH, and say, check for updates. It'll give me a command back and say, yeah, okay, well, there's a firmware update for your BIOS, there's a firmware update for this. Since you've got a Dell branded RAID card and you've got Dell branded drives in there, there's actually firmware for your hard drives that might make performance better, or moreover, might stop them from crashing because they're doing the wrong thing. This is brilliant, because otherwise the command to update firmware on systems, and I know because I just built a system for my partner. I'm a Mac person by day. I see it as an extended DEC term. I don't need to talk about the firmware on my Mac. She's a Windows kid because she does things that are artistic and only available on Windows. And we had to patch for the late gen Intel bug that makes them overheat. And it turns out the answer really is you're still running a DOS executable to update your flash. Like you'll break into a UEFI shell, but you're still saying load this DOS firmware, like phlash.exe. And I don't want to be pushing out DOS ISOs to my Dell boxes to run these things. The Dell iDRAC itself knows how to do these things cleanly. It will cleanly shut down your system, sending the right ACPI commands. It will boot into a nice little progress bar-y thing that you can see on the virtual console. It'll announce it's done. It'll log events to your system event log that you can see in the iDRAC, and they'll boot back into your OS when you do these. I have not seen this kind of good from anything made by Supermicro. I haven't seen this kind of good from anything made by HP. I honestly think the marketplace needs more competition, because I don't like the vendor lock-in, but man, this is sweet and it makes my life easy. My problem there is it's Java. And not only is it Java that wants to install using a Java version of install anywhere, which is basically like your classic Windows install shield. So you need to run the installer in a GUI, which means I need to have a Linux machine with a GUI sticking around so that I can run the installer for this thing. Once the DRM is up and running, it runs as a service, so non-root users can run it. It can run entirely from the command line as well, so it's okay once we're there. But I thought this was such a cool thing. Sometimes I will blog about the day job, and I wrote a Medium article about it because I could not find anything about this. This was mostly a journey of discovery, and week after week, when Medium sends me emails, they're like, hey, this article here has more views than anything else you've written about, anything else that may matter to you. I'm like, that's cool, I guess. Clearly more people are searching for this, or AI really wants to know about this and is trolling my Medium. I'll take it, obviously. For a while, when I searched for Dell DRM update, it was the first hit on Google, which put me above Dell's stuff. That was kind of neat. I thought that was kind of, but it's out there. Kenneth Finnegan also has managed to download a bunch of files from Dell.com. So if you go to updateyodells.net, he's cached all the updates that they don't make available anymore. And you should probably look at those if you have older hardware. They are useful updates. But it bothers me. This is still Java, which the whole point of Java is that it's supposed to be able to install and run anywhere. Why am I not running this under FreeBSD? And that's why this is in my combat stories, is what if one day? I would love to try and make it run, but I run into the problem of, okay, but this is critical infrastructure. Do I want to run it under the OS that they're not saying I should run it under? It's a hard problem to solve. But there's also a Dell tool called RackADM. Anyone who's ever worked with a Dell server knows about RackADM. It's basically a command wrapper that throws commands at your iDRAC and returns specialized responses. And you can SSH to your iDRAC and run an internal version of RackADM, but there are some tools and some use cases that you absolutely need to have RackADM running on either a Windows or a Linux box, which again is disheartening to me. For example, to upgrade the license on your iDRAC, if you've gotten a version of an iDRAC that only has the basic license that doesn't give you a virtual console, you need RackADM to install a new license file. You can't just browse to your iDRAC and drag and drop a license in, which is dumb. You can't easily, programmatically deploy new SSL certs to your iDRACs without RackADM. You can do it for one, but you're not going to do it for 50. And we have enough out in the field that we care about this. Because the day I have to go to one of my devices and click ignore SSL warnings, I want to never have to do that behavior. I put in the work to make sure we have good SSL certs with our own CA, so we keep them licensed. I have discovered that RackADM runs under the Linux emulator. I put in a port for it. I got some interesting questions back about why do you need to pull in these specific libraries, to which my answer was, I don't know, that's what Dell wants. I don't know that that was a good answer, but, but it's closed source software. I know putting a port in for closed source software is complicated and tangly. I know that by putting that port in, I might have, it might not be within the spirit of the license. So I don't know if that'll ever work. And I'd love to speak to people about that. Should I just leave it as an unofficial port? Should I try and push on this? Or what have you? The other thing is that Dell gives you, if you run an agent on the OS side of your Dell server, and again, I'm talking about Dell more than I'd like to, but this is where I live. If you're running an agent on your server, there's a lot of cool things that happen. That your iDRAC, when it has an error, can actually make things show up in varlog messages on your Unix machine. It means that you can actually use the internal commands on the OS side, not the iDRAC side, to do things like completely cleanly shut down your machine in such a way that it's almost as if you'd pulled both power cords to drain all the capacitors and boot back up. That's not available with any other tool. There's a list on Dell's site that lists like 20 advantages to installing the service module. The service module is available for Windows, of course. It's available for all flavors of Linux. Well, not all. There's too many flavors of Linux. But most of the popular flavors of Linux. And it's available for VMware ESXi. So the enterprise platforms. And we have a good relationship with Dell. We buy reasonable amounts of their hardware. They've accepted bugs from us. In fact, some of the fixes to Dell's SNMP MIBs that they ship out are bugs I've pushed. So that's a little point of perverted pride. But I've said, hey, has there ever been thought to this? And the answer I've always gotten is a hard no. That said, I know that if I put a Linux on a Dell machine, I can probe the heck out of it and say, okay, well, what services are running here? Can I K-trace them or whatever? Can I reverse engineer this and make a pseudo Dell service module? It would be a long project, but it's definitely interesting to me as this would be an epic hack to bring us back into the main line of you can do this stuff on FreeBSD too. Yes.
Well, I'm wondering, looking at this list that you have here, why you haven't done more to just bypass because the FreeBSD can happily be configured with the serial console, but then you just SSH at the interface to come in on the serial console of FreeBSD.
Okay, so the question was, why am I doing all this Java stuff where there's a serial console? The Java thing specifically I was referring to is only the tool that downloads the software from a repository and deploys it into a directory on our server. That's Dell's repository manager. It's just a fetch the updates and stuff them over there in some directory reachable via Apache.
You're talking about the Java, the remote screen.
No, on pretty much every modern Dell, your remote screen is going to be HTML5. We've gotten past that nightmare, thankfully. There is a blog somewhere on my site that says, please, please, here's what you have to do to Java to get it to load older screens. And I'm not going to lie, there's a UTM virtual machine sitting on my M3 MacBook Air that'll still boot up Windows XP for what I have to deal with the not iDRACs, but older Supermicros that haven't gotten the right updates to do those because ask a sysadmin. We have a Windows XP machine sitting somewhere to talk to that shit. I said a bad word, I'm sorry, but it really is garbage. The whole idea of Java should be write once and run anywhere is out the window when you try to do this stuff because, oh yeah, it's write once and run anywhere, but with SSL libraries that have been ripped out of your operating system and out of Java, and you have to go in and re-enable the ability to set the security slider back down to medium, and then maybe you'll be able to run it. Yes?
Sorry to interrupt. We are already running more than 10 minutes over. So
Oh, I thought I was till 3:30. I'm so sorry.
No, 25.
I thought it was till 3:50.
At 45, the next the lightning talks begin. So
Oh, I'm sorry. Somebody's trying to throw lightning at me.
Quickly.
I legitimately thought my talk was till. Can you give me 2 minutes to wrap up? Yeah. Okay. I'm so terribly sorry. I was afraid my slide deck would run over or would not last as long. Anyway, 2-minute wrap up, promise. So at the end of the day, we're a small team running critical internet infrastructure on commodity hardware. It's super cool, and a lot of these machines are out in weird places. We try to do it with physical hardware because we don't trust the underlying substrate of here's a VMware with a Docker on top of it, with a thing on top of it, with a thing on top of it, on top of some hosting provider's stack. This thing has to speak to other people speaking BGP at large ISPs, at small ISPs. It's core critical internet stuff. And so it is, we don't trust a lot of, here, I'll just give you a Raspberry Pi to run this on. The other reason we don't do that a lot is because these are announcing our IP space. As soon as we let somebody announce something that's in our IP space and they don't have root on it, there's not only a layer 8 problem, but there's not only a security problem, but there's also a political problem of why have you done this for somebody without serious contracts, and how did you vet these people? We've run a few VMs for FROOT. I will say the one place we've run it for obvious reasons is in Ukraine. We have totally said yes. For you guys, VMs can work for right now. We need to talk about a more permanent solution, but at the moment, we work with what you got. We've also deployed systems with, I was talking to Alan Jude at the ZFS BOF. These machines are deployed with unique passwords that we keep centrally. So if you were to break into our machine and look at our Etsy password, all of our main accounts are just going to have stars in them. There's got to be a root password because there's got to be, but it's unique per device. So if you want to sit there and brute force our root password, it's going to be, you're only going to get the one that's good for that box.
All right, next session starts in 5 minutes.
Yes, I'm wrapping up now.
Okay.
Yes, thank you. Sorry. Please don't throw more lightning at me. But I have looked at the idea of booting those systems up in a way that they could boot up read-only and then phone home to get a key based on their TPM attestations. I saw a Juniper talk in this exact room about 5 years ago talking about the TPM work. But at the end of the day, what we're serving is public data. You can download the root zone yourself. It's not a secret. It's just we'd sleep a little bit better at night. If you really want to capture our traffic, it's a plain text protocol. You can do that on the wire without compromising our box. The DNS is still complex. There's a great talk by Bert Hubert called the DNS Camel, where we keep talking about how more and more people are loading things onto the DNS until it breaks. We've experimented with small deployable boxes like Raspberry Pis and Minnow boards, but we run into the problem I mentioned earlier, which is that we won't let people announce our IP space. And my last bullet point is, and other people have touched on this, this is critical infrastructure. This is literally core functioning of the internet. As cool as some of this stuff is, I really like it when it's not exciting. I'd like it to be stable. I'd like to be able to sleep at night and not have, not try the next whiz-bang thing. So it's been a careful journey of steps, but there's definitely been some fun stories to tell. And that's it. Sorry for the overage.